In this session, we will take a look at TIBCO BusinessWorks 5 project, which is a file-based project shipped out of the box from TIBCO. And this is TIBCO Designer. On the left-hand side, you will see the project panel where the project files and folders uh, persisted on disk are available. And we have multiple tabs here: global variables, tester, palettes. We will uncover these as we go through, and there are different types of palettes available, and for this particular project we'll be focusing on file palette, and there are different activities present in the file palette. For example, these are the activities available for file palette: copy file, create file, file puller, list files, read file, remove file, rename file, wait for file change, and write file. And the names are pretty intuitive, and they suggest that what the particular activity does. And we have almost used all the activities as part of this file-based project. And on the right hand side, on the top, you will see the process canvas where developers can design and develop a BusinessWorks 5 project. And the bottom, you will see the configuration panel. What are the multiple options available to configure these activities? And on the project panel, you see the project folders and files. And there are two types of files available. There is a golden color process definition files, and on one of it you will see a green play button, and the other one you do not see that green play button. What does that mean is this application process flow starts in this process order process definition where there is a play button available, and the other process is a sub process which is called inside of this main process. We will be uncovering it in a while, and these are the schema definition files which are used in this project. So, and if you see here, when I click on the main starter process, inside the brackets, this is the name given by TIBCO, which is called process definition, and you can name it anything which is meaningful. And the best practice is it should say what that particular process does. And in this case, it is process order, which means it processes some new orders in a business. And likewise, when we click on the activity, it will tell you the actual name of that activity, what it does. And in this case, it is a file puller, which is a starter activity. And you see the play button on it, which signifies that this is a starter activity. This is where the process flow starts. And in the other case, in the sub process, you will see just a start and end, which means that this is a sub process and not main process. Like I said, this is file puller, and the name suggests that it's listening for new order files. And the file name is defined in a global variable. If you go to the global variable tab, you will see the file name BW new order file, which is coming from project files inside the project, and it's BW new order.xml. And let's see what it looks like. This is the BW new order.xml, and when we click on the source, you will see the nice XML structure, and the root element is order. The customer name is Hank Hill. Ship to address is given: street, city, state, zip code, country, and items that he ordered, like item number 9876, and the quantity is 1. Item number 5612, quantity is 2, and the total price is $123. And there is another XML file which is used as part of this project. Let's see what it is, and we will see in a while how it is used. And there is a shipping costs rule element under which, based on destination, it is defining what is the total shipping cost. For example, if the region is USA and the max purchase price is like $50, then the shipping total is $120. And likewise, if max purchase price is $250, the shipping cost is $40. And for EMEA region, we have different shipping costs. And for Australasia, which is Australia and Asia region, there is a different shipping cost. And Americas, as we have seen USA already, rest of the Americas like Canada or South American countries like Brazil or Argentina, there is a different shipping cost. Okay, now let's go to the main process where the flow starts. And this particular process waits for some new order file. And as and when it receives a new order file, it will parse the order file. Parse XML is the actual name of this activity. And this is the name given by the developer, parse new order file. Basically, this activity takes a text input from the file poller output. This is the text content. And inside parse XML, you'll see this is coming from text content from the file poller. And then this activity converts text to an XML format. And here you can see a nice XML structure that we have just saw in the PW new order.xml. Then there is a create file activity which says create approval file, and we will see what that is in a minute. And then we have to calculate the shipping cost. For that, we are taking the total order price from the new order file, and then the destination from the ship to country. And then we have to read the shipping cost XML, then convert it into nice XML structure. Then on the end activity, I see there is an XPath to calculate the shipping costs. Then we get the shipping cost from here. Then there is a wait for approval file change. Basically, it is a wait for file change activity inside the file palette. This is the one. And wait for approval file change is something which is trying to imitate a manual process or a manual step in a real-time business. We will see how does that work. And then after the approval or denial or whatever it is, we have to remove that approval file, because this is an intermediate file that is created for the process flow, and we do not want to keep that file, and the file will take some space on the server in real time. We do not want to waste resources on the files which we do not need anymore. So we have to delete it, and basically it's a remove file. Then there is an XPath condition for two different flows. One is if the order is approved, and the other is if the order is delayed. And then there is a customer notification file, which is a write file. And let's see how this customer notification works when we try to run the business flow. All right, let me try to run this process definition flow, and we already have a new order which is coming from TIBCO. Let's see how this works. When we select the play button here, we will see select processes to load. We don't need to select this one because this is called by the main process. We need to only select the main process, and I will choose load selected. Okay, the process has started, and we can see the text content from the new order XML, and it is converted from a text to a nice XML structure. And then we see a create approval file here in the project files. Let me refresh. You see, this is the business BW approved order, and we have to say here whether it is approved or delayed or whatever it is. And then let's go to the next. And we will see this process will wait until some manual step is performed. And then the next step is remove that approval file. So it will be removed. And then based on order is approved or delayed, customer notification file will be generated. So let me approve this file here and apply and save that file and see what happens next. Okay, so here BW approve order, which is approved, and let's see it removed the approval file. Let me refresh and see if it is removed. Okay, it's removed, and I don't see that approved file anymore. And what happened next is it went in order approved flow because we approved it, and there's a customer notification file which is created, and this is a customer notification. And let's see what is happening here. Hey Hankel, your order has been approved. The cost is as follows. Purchase cost is $123 and shipping cost is $40 and total cost is $163. Let's see how this shipping cost $40 is coming. Here in the shipping cost XML, the country or region is US and the max purchase price is 123, so it will not fit here. And let's see here, max purchase price is 250, which is fitting our criteria. Like $123 is less than $250, so this is the shipping cost, and that is what we see in the final customer notification file. That shipping cost is $40 to ship, and the total cost Hank has to pay is 163. I'll stop here and continue. In this session, we will take a look at TIBCO BusinessWorks 5 project called JDBC Test. And this is TIBCO Designer. We have covered the file palette in the last session. And in this session, we will be focusing on JDBC Palette. And in the JDBC Palette, we have certain activities like JDBC call procedure, JDBC get connection, JDBC query, JDBC update, and SQL direct. And for this particular process, we will be using JDBC query and JDBC update and use a write file to write an output file. This is a sample project shipped out of the box from TIBCO, and these are the SQL queries which we need to run before we can test this BW5 project. First, we are trying to create a table. The table is created now, and there is another table which is table suborder. Table suborder is also created now. And we have to insert certain data, which is given by TIBCO. This is inserting data into order table. And the next one is inserting data into a suborder table. With this, we finish certain pre-tasks to run this JDBC process. And this is a timer activity which runs one time when we run this process. And in the JDBC query, we are trying to select the order ID, order description, order price from the order table. And we have to give the order ID. And this question mark, we can map it in the input. And this is coming from a global variable called order ID. And order ID is 142. And the next step is to update suborder table and set the order description and order ID. And we can see the input is coming from JDBC query, which is this one coming from order table. Let's try to just see what is there before we run the process. The table name is order table. Okay. Okay, the order ID is 142 and the order description is testing JDBC connection. Order price is $3,000. Let's see what is there in the suborder table. Bad at remembering the table names. So just suborder, not table here. Okay, so order ID is 142 and order description is destination record and order price is 2000. So in this process, let me run both at a time. So in this process, we are going to update the suborder table description and order price from the order table. So by the end of the process testing, we should see the description is going to change to testing JDBC connection and the order price to 3000 instead of 2000 in the suborder table. Now, let me see if the JDBC connection is set. Okay, this is coming from TIBCO for our local database. I need to change it to Uh, this is what my local credentials are. Let me test this connection. That's perfect. We are now connected to my local database. Apply and save. And now go back to our process. And this is a tester tab. And I'm clicking the green play button and load selected. The testing engine is being started. Okay, so I know what this is. Basically, there is no temp folder in my local machine. So what I'll do is I'll try to select this option, create non-existing directories, and apply, save. So let's see what is there in the JDBC query. We have input the order ID 142 and the output is coming from the database testing JDBC connection, and the JDBC update, we are trying to input from the description from testing JDBC connection, and the update is successful. And let me rerun the select statement here. Okay, it has updated to JDBC testing, JDBC testing JDBC connection. I thought they were updating the order price, but that is not the case. But what we will do, we will try to update the price this time. So here we have the record and order price. And in this case, I will change the order description to, what is that? Order price. And instead of varchar, I'll make it integer. And okay, I will make it, since the output is coming as float, I'll change it to float. Okay, now it is changed to float, and I need to map the order price instead of order description, and that is done. And here I have selected create non-existing directories options enabled, so it should not fail this time. Let me rerun it, and the final result will be this order price in the suborder table will be 3000, which is coming from the order table. And let's see. Okay, I've got the JDBC query output from the order table. The price is 3000, and here in the input data we have the order ID 142 and price is 3000 this time, and the output is number of updates 1, and this time the file is written and the message is written, records written 1, and end the process. Let's see in the database if the order price is changed in the suborder table. Now it is updated to 3000. Let's take a look at the output file written. So this is the output file written by write file activity, and the messages records written is 1. I'll stop here and continue. In the previous session, we have uncovered the JDBC palette, and in this session, we will take a look at JDBC transaction. This is TIBCO Designer, which is used by developers to design and develop TIBCO BusinessWorks 5 projects. And on the left-hand side, these are the project files, and we have multiple tabs available: global variables, tester, palettes, and we'll explore as we go through. And on the right-hand side, we see the process canvas, where we design our business process flow. And this is JDBC transaction project, which is shipped out of the box from TIBCO. And on the bottom, you will see the configuration panel, where you will be able to configure each and every activity which is used in this flow. I'll try to explain this flow, what it does, and what is the role of the JDBC Transaction Group here. If you see this process definition, you will see a green play button, which is essentially signifies that this is the starter process where the flow begins. And it's a timer-based starter process, and you see the play button on this activity, which signifies that this is the starter activity. And this is where the flow begins. And this timer process is configured to run once when we test or trigger this flow. And the next step is a Java code activity, which is trying to generate test data. And the next group, this rectangular box, is a group called JDBC Transaction. Here you see the group action as transaction, and the transaction type is JDBC, and inside which there is some logical functionality which occurs. And we have to design our process in such a way that, for example, there is a business scenario where you have to take part in a transaction, which means that this transaction either should pass or fail only if the entire business functionality inside this group are passed, and it should roll back if any one of the activity fails inside this logical group. And that's what is tried to mimic some business, real-time business flow. The first JDBC update is trying to insert some data into BW transaction test table, and the second JDBC update is trying to insert data into BW transaction test 2 table. And here there is some real-time mimic where the transaction should abort based on a global variable value. Here, the abort JDBC transaction is false, and in case of false, it's going in the success flow and ending the process. And if abort JDBC transaction is true, then it will generate an error, which is the intent of this process design. And in case of error, these two JDBC updates should roll back. and it will go in the error flow, log some error message, and end the flow. This is what this process flow is about. And let's try to run this flow. And before running this flow, we have to create the tables which are used by this JDBC activities. And another important point to remember is that these two JDBC activities should be using the same JDBC connection in order to take part of the transaction. The second thing you need to remember is, since this is a JDBC Transaction Group, any other activities like JMS transaction will not be rolled back in case of failure scenarios. Only JDBC transactions will be rolled back. That is important to remember. And let's begin. I'll try to create the two tables. The first table is created. The second table is created. And before we test it, let's just run a select statement. We know that there is no data already in these tables. This is table 1, and this is table 2. We're just running it before we test the flow. Query 1, no data. Query 2, no data. So back to our process flow, and in the tester tab, we have a play button. Click that one and then select the process name and click load selected, and data is inserted. Here the data is inserted and the board is false, so it went into success flow, and we should see the data inside the. So query 1, query 2 has data in both of them. Now let's change the abort transaction to true. Save and stop the tester and rerun it. And it inserted but generated an error. In this case, we don't see the data inserted. Let's see the database. We only see one data set. So let's change it back to false again to see if we can insert the next set of data successfully without having any transaction failures. Rerun it. This time it went inside the success flow. Let's see the database again. This time we have two data rows inserted. So This is how the transaction group works in TIBCO Business Works. I'll stop here and continue. In the last session, we have seen how JDBC Palette or activity works in TIBCO Business Works 5. And in this session, we will see how a SOAP over HTTP web service is implemented using TIBCO Business Works 5. And this is TIBCO Designer, which is used by TIBCO developers to design and develop and unit test business workflows. On the left hand side, you will see the project panel, and we have different tabs available, like global variables, tester, palette, and we are exploring these tabs as and when we go to implement or test these application flows. And if you see here, there is a green play button on this process and this process, which signifies that these are starter processes. And there is a sub process which is called inside of this main starter process, which is the web services implemented using SOAP activities. We will try to uncover what these activities and the flow does. This is a SOAP event source, which is basically configuring the web service. And if we see the output of this SOAP event source, there is a parameter called author, which is coming from the client application. We will just explore the client application in a minute. And based on this author, we need to query a bookstore and get all the books written by this author and send back the response to the client application. That is the high level overview of this business process. And here in the input, we will send the author parameter inside the subprocess, where this subprocess is just mimicking a real-time business application where this is a business bookstore, and we have to get the books written by the author when we send the input as the parameter, author as the parameter input. And this is a read file activity which we have uncovered in the file palette session, and the file name is coming from the global variable called read bookstore XML. And this is the sample project which is shipped out of the box from TIBCO. So the value we see here is from the TIBCO site's path, but we will try to change the path to the actual one. I believe this is the path of the bookstore.xml. Yeah. So basically, this bookstore.xml is trying to mimic some bookstore in real time, and it has the book root element, bookstore root element, and inside which we have books, multiple books information like title, author, date, ISBN, publisher, things like that. And this web service will take the author as the input parameter and call this bookstore process and send the books information from the bookstore process, like what is the title, author, date, ISBN, and publisher. And this is the client application, which is trying to mimic some real-time client application, which is a timer-based process which runs once when we trigger it. And this is the send SOAP request reply activity where the input will take the parameter author, and in this case the name is Vivek Ranadev, and we should get the response of what all books he has written. Having said that, let's save this project and try to run this application or web service. The first process to trigger is the web service client, and then when it triggers, it goes to the query books by author web service and gets the response from there. Okay, so the input parameter is Vivek Randev, and let's see the output. We have got the book names which are written by him, which is The Power of Now, and the publisher is TIBCO Software. And let's go to the main web service process. What happened here? Here the SOAP event source output we got, which is a post method, and the input parameter is where is the author name? I was trying to locate the author name. Yeah, sorry, here, the first line. Vivek Ranadev, and then go to the bookstore process, read the bookstore XML, parse the bookstore XML. Here we have different authors, and then on the end activity we have a filter on the author, like here in the variable the author coming from the star is set, which is Vivek in this case, and it will only list all the books that are written by Vivek based on this condition. It is trying to match the author coming from the bookstore XML and the variable which is coming from the start of this process, which makes sure it only lists the books written by Vivek. And coming outside of this process, we have a SOAP send reply, and on the input, we map it from the bookstore call process. So the input data to this process, to this activity is the book title, author, date, and this response will be received on the client application on the SOAP request reply. And this is what we got. And this is the sample TIBCO BusinessWorks 5 project, which is a SOAP web services, SOAP over HTTP web services. I'll stop here and continue. In the last session, we have uncovered SOAP Palette and how to implement SOAP over HTTP web service using TIBCO BusinessWorks 5. And in this session, we will try to uncover JMS Palette and how a queue receiver works or is implemented in TIBCO BusinessWorks 5. For this, we need TIBCO Enterprise Message Service, which is a messaging system from TIBCO. And I have started the Enterprise Messaging Service in my local machine. And this is the EMS admin tool where we can see what are the queues that are currently available in my machine. And this is queue.sample, which is used in this project. And this is TIBCO Designer, which is used by TIBCO developers to design and develop BusinessWorks 5 applications. On the left-hand side, you'll see the project panel, global variables, tester, palettes, and we are exploring these panels as and when we are going through each of these options. And these are the project files. This is a queue receiver project, which is shipped out of the box from TIBCO itself. And this golden play button, this process definition is the starter process, which signifies that the process flow begins in this process. And this is JMS Queue Receiver activity, which receives messages on a specified queue, which is queue.sample in this case, and the message type is text, and it logs the message which is sent on the message queue in the body of the message, and that's the end of this process. For this, we need to connect to our EMS server in our local machine, and this is the JMS connection shared resource. I'll test this connection, and test connection is successful, which means that this queue receiver is able to connect to the local EMS server. In order to put some messages on the queue, I need to create a process which can send messages on the queue which is specified in the queue receiver. I'll name this process as queue sender y, and go to palettes, JMS palette, locate the JMS queue sender, and connect this transition from start to queue sender, then to the end. And let's define this JMS Queue Sender. I'll use the same JMS connection, and the queue name is queue.sample. The message type is text. And for now, I'll set it as test message 1, and either I use double quote or a single quote. I'm using double quote here. And first I'll try to send the message on the queue. Message is successfully sent, and the message is test message 1. Now let's see if my queue is created. The queue will be created dynamically because I have created a queue name called greater than symbol, which means that any queue which will be used in the application and not created in the or not created before will be created automatically. And I see one pending message here. Let's try to send another message, and this message I'll say test message 2. I need to stop in order for the change to get affected and test it again. And let's see if I have 2 messages now. I see 2 messages pending on the queue, waiting to be received. So this time I will trigger the queue receiver. The message is received. The first body of the message is test message 1, and here the input data says request test message 1 and next job. The second message is test message 3, and the message is received on the queue receiver, and this is a log message. I'll stop here and continue. In the last session, we have explored JMS Palette, and this is a sample queue receiver project which uses JMS Queue Receiver to receive messages on the specified queue. And in this session, we will try to receive the data from the JMS Queue Receiver and insert that data into a shared database. And on this is a TIBCO designer, which is used to design and develop TIBCO BusinessWorks 5 projects. And on the left-hand side, you'll see the project panel, global variables, tester, palettes available. And we are exploring all these palettes and other panels like tester, global variables as we are going through. And this is the queue sender process, which we have developed in the last session. We will try to reuse it and add some additional activities from JDBC Palette to insert the data into the shared database. I'll use the JDBC update activity, connect this JDBC update to the end. Also, we will use a parse XML. We will take an XML input from the JMS Queue Receiver, parse it, and then insert the data into the database table. On the parse XML, I'll put the input style as text. I'll not validate the output, and in the output editor, I'll add the fields I wanted to insert into the database. Let me take this order ID table saw in the previous sessions. I'll rename them as order ID and put it as optional. And let me put the order ID as integer. And the next one is order description. Make it optional and leave it as string. And the third one is order price. And I'll set the order price as optional and integer, or maybe order price, I'll define it as decimal and I'll set it as float because we may have decimal price values. So, and here I need to create a JDBC connection, which I'll take it from JDBC Palette, JDBC connection, and I'll have the JDBC connection URL. The database URL is this one, and it's Oracle Tim. Apply. The username is system. Password is apply. And let me test the connection. Test connection failed. No JDBC driver. No, this is not possible. Let me fix this. I fixed the database URL format. It should have the colon instead of forward slash, and JDBC test connection is successful now. Click OK and use this JDBC connection in this. Let's rename it as JDBC insert. In this JDBC insert, choose the connection, JDBC connection, and now let's get the insert statement which we need.
Here, insert into order table, and we have 3 values. We have to add 3 values here. The first value description is order ID, and the data type is integer, and the next column is order description. Let me leave it as varchar. That is fine. And the next one is order price. I'll set this as float. Where is float? Okay. Apply. And now I need to map these fields from the parse XML, which we receive on the JMS Queue Receiver, parse that XML, and get the individual fields here. I've mapped it. With this, I think we finished the development phase. Click Save, and let's test this sample. For this, we need one sample XML, and this is the sample XML that I have. The order ID is 143. The order description is Apple AirPods, and the order price is 164. First, let's query the database. What is the current record count? We have one record, order ID 142, so I have taken the next order ID is 143. Now run it. Here I need to add a parameter for mapping the XML input to the queue sender. I'll map this parameter instead of the test message that we did in the last session. Here in the supply input data to the starter process, I click and paste the XML input. Let me run this flow. I'll first send the message. Message is sent. Let's see in our EMS admin tool, if still it is connected, we have one pending message. So I'll stop it and run the queue receiver now. Load selected. The parse XML failed. Oh, I forgot to map the input from the JMS Queue Receiver. That's my bad. This is an auto acknowledge, so once it is received, then the message is gone from the queue. So we need to rerun the sender. I reran the sender this time. Let me check the queue pending count. We have one message. Stop this one, then run the queue receiver process. Okay. The message came through. I'll see the output of this one. The order ID is 143, Apple AirPods, order price is $164, and then it went into the JDBC insert, and the mapping is 1-to-1. Then the number of updates is 1 record inserted. So let me query the table again. We have 2 records. AirPods, order ID 143, order description Apple AirPods, and order price is $164. Now I'll try one more example. This time I'll put it as iPhone. Let me put the price as $1,064 this time. I'll stop this receiver, go to the sender, change the input here. I've changed it. This time I'll run both the processes at once, load selected. The first process is to sender, and the second process is receiver. This time the parse XML got the iPhone details and the insert is successful. And let's query the database. We have inserted successfully the iPhone order details. Okay, I'll stop here. Imagine this is a real-time integration scenario where messaging is being used in one integration solution and shared database is being used, and we are using JDBC and JMS Palette and XML Palette, Parse XML to design and develop this real-time integration solution. I'll stop here and continue. In this session, we will try to uncover how avoid and notify activities work in TIBCO BusinessWorks 5. This is TIBCO Designer. On the left-hand side, you'll see the project panel, global variables, tester, palettes available, and we are exploring as we are going through. And this is a sample repository shipped out of the box from TIBCO, which is having a notify process, on notification timeout process, and wait process. And let's try to explore what each of these processes does in real time. The first process is notify process, which is a timer-based starter process, which will be triggered once when we test this process, and then we have a notify activity, which is using a key, which is a correlation identifier between this process and the wait process or the on notification timeout process, which we will just see in a bit. And this timeout is 3 milliseconds, and this is the message we are sending. It's simple hello world message. And then we have logger activity, which is stating that it is executing the notify process and then end this process. And let's go to the wait process, which is again another timer-based process, which triggers once. And certainly we can configure this to trigger in regular intervals. And this is the wait activity, which will wait for the notify activity in this process. And here we have the key again as key 1, which is the correlation identifier between these two processes, which is matching in this case, and the timeout is 3 milliseconds again. For example, I will not set any timeout here, which means that it will wait until it receives the a response from notify activity. And the next process, which is on notification timeout, and this process will trigger in case of any timeouts on the notify activity, which means that it is not able to communicate with the wait process for some reason in real time. And this will trigger, and it is trying to log the same message and ending this process. We will try to mimic some real-time scenario so we better understand how these activities communicate in real time. Instead of hello world, let's say customer order let's say customer placed an order. This is my message. For example, I'm ordering some iPhone or something like that. So this is a message to notify. And in the wait process, there is some, for example, there is some business logic which will uh, take care of the customer order. And on notification timeout, we will log the same message with some additional details. I'll concatenate this message and say, but customer placed order, but order management application is down. Please take appropriate action. And this is my message. And in real time, imagine a situation where you are the owner of this application and your team is responsible for completing or fulfilling this order. Then you will receive this notification in your team email box saying that this application is down. And here, let's add some additional logger. Which says order fulfilled. And this finishes our design time. Probably I'll clear the console and keep it this way to see what's going on with our application. I'll go to tester, click the play button and select load all the processes which I have configured here and load selected. Then I'll click the console here, let's go here first. The process triggered, notify activity triggered, the messages customer placed an order, log messages, executing the notify process. Then let's go to the wait process. And here we have received the message from the notify customer placed the order, and log message says that order fulfilled. You have to imagine that there is some business logic in real time which took care of the order, and this is just a logger message after the order fulfillment is completed. For the benefit of time, we can easily mimic some real-time logic where order is fulfilled, but for the benefit of time, other people's time, we are uh, just logging the message that order is fulfilled. And let's see the console and the series of events that took that happened. Okay, so we have triggered the processes, and you can see on notification timeout process started, but it didn't get triggered because there was no timeout situation here as of yet. And the first log message is coming from the notify process saying executing the notify process where we received the customer order. And in the wait process, we do some real-time logic and we fulfill the order which we received from the notify process, and the log message says order is fulfilled. Now let's stop this and go to these processes, and we have the timeout set as 3 milliseconds, and we have the wait process. For some reason, we do not send an acknowledgement to the notify process in time because we have some other business logic in between, uh, which didn't finish in time. So just to mimic that situation, I'm just adding a sleep activity, and the timeout on the notify process is 3 milliseconds, and I will sleep for 1 second. In this scenario, this is some real-time business logic where I'm calling some external web service or making a database call or waiting for some message to be received from some messaging system in real time, things like that. That is what I'm trying to mimic here. So it is taking 1 second for me, and I'm not able to get or acknowledge the notify message on this wait activity. And now let's see what happens. The ideal situation is on notification timeout process should trigger this time. And bear in mind that on notification timeout activity works in 60 seconds interval. For 60 seconds, it will go see if there are any unacknowledged notify messages. And if there are any messages, then this process will trigger. In the earlier case, here we have the timeout 3 seconds, and within 3 milliseconds, within 3 milliseconds, our wait process has acknowledged that message, and this 60 seconds, in this 60 seconds of time, that message will be removed from uh, the timeout activities queue. This is all internal, and we should not be worrying too much about how this mechanism works. But bear in mind that this triggers every 60 seconds and sees if there are any messages which do not have acknowledgement, then this process will be triggered. If you have to decrease the time in which it will trigger 60 seconds. If you want to decrease it or increase it, you can do by changing the configuration files inside of TIBCO BusinessWorks, which is out of the scope for this demo. Anyways, I'll start the timer process and load it and see what happens. Here, the notification process has sent the notification saying that customer placed order, and we have come to the wait process. I think I let me increase the timeout here and stuff. 1 second, I'll increase it to 10 seconds and let me rerun it because I wanted to wait in the wait process and not send any response to the notify process. And I think I need to make this timeout more than 60 seconds because my on notification timeout will trigger only after 60 seconds. And also let me clear my console and keep it ready for the next execution. And this time I'm sleeping for more than 60 seconds for sure. And we already saw the notify activity has sent the message. And where is my console? Here on notification timeout process started. Uh, notify process is executing or it's completed execution. And this is around 20:06 seconds. And let's see what happens in 60 seconds. Okay, now our on notification timeout process has been triggered because it's more than 60 seconds and the customer placed order was not acknowledged because the wait activities wait process is waiting on some external call, which is the sleep activity. And that is the reason on notification timeout process got triggered and sent a message to the application owner saying that customer placed order, but order management application is down. Please take appropriate action. And this is how wait and notify and on notification timeout activities work in BusinessWorks and how to leverage them in real-time business scenarios using TIBCO BusinessWorks. I'll stop here and continue. In this session, we will try to uncover how to implement a web service using TIBCO BusinessWorks 5. And this is TIBCO Designer, which is used to develop and design BW5 applications. And on the left-hand side, you will see the project panel, global variables, tester, palettes. And we have seen in our earlier sessions the file palette, JDBC palette, JMS, and SOAP palette, XML activities. And in this session, we will explore the service palette, and we will use this service resource to create a web service. And this is the project panel. These are the project files. And inside the service folder, we have the web service implemented, and we have two operations available in this web service. The one is get city info, and the second one is get city distance. We will just see what these two operations does in a minute. And the endpoint is SOAP over HTTP, and these are the SOAP details. And we have the WSDL source tab where we see the concrete WSDL. We use this in SOAP UI to test this web service. However, we have test service folder where we have two operation testing stubs. The first one is get city info, and this is the SOAP request reply, which we have uncovered in the previous sessions when we were discussing SOAP palette. And here in the input message, you will give the zip code, for example, 61801, and in the output, we will get the city info, the city name, state, location, latitude, longitude, and zip code. And in the get city distance test, here the input will be the from zip code and the to zip code, and in the output we will get the distance between these from city and the to city, and it will also give us the city info for both from and to, with city, state, location, latitude, and longitude. And let's see the actual implementation, what's going on here in the response. For get city info, we have the city name, state name, location, latitude, longitude, zip code, and this is a sample project shipped out of the box from TIBCO. The whole idea is to see how these service resource and SOAP request reply activities work. So the implementation will be simple, and you can imagine in real time there is some fancy processing here happening to get this info, and we just map it to the end activity. And in the get city distance service, you will see we have the from city and to city distance, from city and to city information and the distance between them. And again, we can have some implementation in this operation to find out and calculate this distance in real time. But since we are focusing on how these activities work, we are putting the logic or business logic as simple as possible. So this is about the application design, what it does. Let's try to test these two flows. Go to the tester tab, and you can select the service resource, and in the test service we can select both of them, and we will test one by one. Load selected. So let me trigger the get city info operation first. This is triggered and the input is a zip code 61801, and then we got the response that the city name is Urbana, Illinois, and the latitude and longitude and the zip code again. And if we see the service resource, we can see the get city info service got invoked. Let me try to invoke the get city distance operation. Here I have the input data as 61801 and 61820, and we got the from city information, which is Urbana, Illinois, and longitude and latitude information, and two cities, Champaign, Illinois again, and latitude and longitude, and the distance between them is 4. And if we see this job, this triggered the get city distance service operation. So in real time, there can be a whole lot of complex logic in between the start and end, which we are just trying to mimic between start and end and putting the end result on the end activity. So whatever is mapped here on the end activity will be the result for your web service, and you will see that here in the SOAP request reply. I'll stop here and continue. In this session, we will try to uncover more complex JDBC sample project shipped out of the box from TIBCO. And this is TIBCO Designer, which is used to develop and design TIBCO BusinessWorks flows. And on the left-hand side, you'll see the project panel, global variables, tester, palettes available. And on the project panel, you'll see the project files. And we have two processes. We will try to uncover one at a time. And the process in subsets. Imagine a situation where in real time you have to query a database table and process all the available records in that database. So you can use the JDBC query activity to fetch the records from the database. And if you see here on the configuration tab, you have max rows set. In this case, it is 100, which means that it will fetch 100 rows from the specified table. In this case, it says SRC order table. And in real time, you need to process all the records available in this database table. And how do you do that? You do not have the number of rows available in that database, and it's possible that you can count the records from the database using some database tool, but that table might get updated in real time by some users, and you need to process them. For example, you queried the database to see how many records are available. Say, for example, you have 1,000 records and you set it as 1,000 in max rows. So which will fetch all the 1,000 records. But somebody updated the database table with some 100 records more. So you will not know that information. So you have to design a process which will fetch all the records available from the table without you even knowing how many records are available. And how do you design that? And the next use case for this process design is, for example, you have 100,000 rows. You cannot set your max rows to 100,000 because that might have some performance degradation issues. So you have to process them in batches. So this is another use case where you have to consider max rows to be in a reasonable level. And in this case, we will stick to 100. And how to design this process is to use the subset size. For example, this global variable, which is coming from subset size here, 5. So this this subset size is overriding the max rows here. So if you define the subset size here, first of all, this subset size will be showing up here when you select process and subset. And when you deselect it and apply, this subset size will be gone. So when we run the select query, it will fetch 100 rows max. When we click this process and subset, then in the input tab, it will ask for subset size. And we set it through a global variable, and the subset size here is 5, which means that this query will fetch 5 records at a time. It will ignore the max rows 100 here. The input tab subset size takes precedence over the max rows, and you will get the records here. And how do we know that we have processed all the records? Is this last subset will be coming as true when this query executes for the last time. And that's when we know that we have processed all the records from the table, in this case, SRC order table. And here we have to use the grouping mechanism in order for this query to be iterated multiple times until the last subset comes as true. And for this, the group action we use is repeat until true. And the condition here is until the last subset comes as true, this query has to repeat. So for all the rest of the cases, this last subset will come as false, and for the last subset, it will come as true, and that's when the group will exit. And here, this is a simple write file, writing some output file with all the records that is fetching from the database. This is basically mimicking some real-time scenario, what business logic you're implementing using the database records from this table. So we will first try to run this example before we go to the batch updates process. And before we do that, we have certain pre-tasks to be completed, which is creating this table in our local database here I have, and this is the SQL query to drop the table just in case if it is already created, and then create the new table called SRC order table. I'll run these both queries at a time. Okay, first the drop table doesn't exist, and that's fine, and create table is created here, and then let me go to the next table, which is actually used in the batch update process, I believe. I'm yet to check the details, but I'll create the table beforehand we go to the batch update process. I will create this one. The table is created, and let's go to the designer. Here I will open the console, clear the console, and start this process in subset. Hold on, my bad. I need to set the connection, JDBC connection. This is something which is preset by TIBCO. I need to change it to my local connection. This is my JDBC URL, and username is system. Give the password and apply, and test the JDBC connection. 1 second. Article then I paste the URL. I think this is in the right format. Host name, colon port, colon instance name. This is looking fine to me. Test connection again. Okay, it got connected. Test connection successful. Click OK, and then go to the process and subsets. Invoke the tester, use load and start current process. And this is the file which is getting created. The process and subsets output file is in C drive. I don't see the file getting created. Let me see what's going on here. Okay, I think I missed to insert the records given. So select star doesn't have any records in it. I need to insert some records here, which I missed. run all of these at once and commit. And now try to rerun the select here. So we have data in the table this time. And let me rerun this process. This time I got an error in the right file. Okay, it says the C process in subset.txt was not found. I will select this option, create non-existing directories, which will make sure if the file is not available, it will create it. And I will stop it and rerun the process. I think the C drive is causing issues. I'll try to put this output file in a temp folder instead of the drive itself. It might have some permission issues with the C drive directly. So I will create a temp folder and then put the file inside that. And this time it should work. Okay, looks like it went through. Now let me go to my C drive and see some temp folder got created and my output file got created. Let me open this file in Notepad, and these are the 15 records which we have in the database that we inserted in the earlier step. So column number 15, which means 15 records from the database, are processed in subsets of 5. This is how we should deal with a large chunks of data. If, for example, we have 100,000 or probably a million records in the database, we cannot crash the process by fetching all rows at a time using this max rows. We set this at a million, then this will have performance degradation issues. So this is how we should process in subsets. So we can certainly increase the subset size. This is a sample and we have only 15 records in total, and that is the reason we set the subset size at 5. But for example, if you have million records and if you are sure that your process or resources you have can handle 5,000 records at a time, then you can certainly set it to 5,000. Now, the next process is about batch updates. So we have in real time, in several different situations, we have certain requirements where we have to insert a lot of data from some upstream which is coming through. And for example, we have 100 records or 1,000 records coming from our upstream, and we have to insert all of them at once. So we have to use the JDBC update to insert, and we can use this batch update setting to insert multiple records. So here, if you see, we are querying the database source database table, and then we are updating it into destination order table. And here, if you see, the record is for each, and we are using the output from the query source table and mapping all the records for each For example, if I remove this batch update and see here, as soon as I remove it, the record is not getting iterated, which means that if we remove the batch update, we can only insert one record at a time. So for batch update, we have to select this option. And as soon as I select, then a record is able to take multiple records at once, and we have for each from the source table. And this is some write file which is echoing how many updates we did. And the next step is to query the database and fetching max 100 rows. And then for each record, it is creating an output file. So let's see. And it is not creating an output file for each record. It is appending the content for each record in the same file. And let's see how that works. And here also we have the batch update output file in C drive. So in order not to have permission issues to C drive, we will just write this file to the temp folder inside C drive. So now let me rerun, not rerun, run this batch updates process and see what happens here. So query source table, we have got 15 records, and then batch update, we are trying to update the order date to current date, and rest of them are as is. And then we have the output file in the batch update. The number of updates are 15. We will take a look at the batch updates text file in a minute. And then we have fetched the records from the destination order table, and we have all the records fetched from that table, and then we are trying to append the result record, each record in this batch update.txt file. Let me open the batch update file here in the notepad, and we have all the 15 records inserted with the date to it. And then the first one is how many updates we did for this table, which is 15. And this is how we deal with large chunks of data in a database, whether to insert large chunks of data which is coming from upstream in a batch update. You have to use batch update option available on JDBC update. And if we have to fetch all the records from our table and process it, then we cannot use the max rows. We have to use the process in subsets option, and then set the subset size, and then process in chunks. And I'll stop here and continue. In this session, we will try to uncover how to implement a HTTP service using TIBCO BusinessWorks 5. This is TIBCO Designer, which is used to design and develop BusinessWorks 5 applications. And on the left-hand side, you will see the project panel, global variables, tester, palettes. And in this example, we are going to explore HTTP palette. And this is HTTP connection, which is listening on localhost and port 8089. And in the process, this is a HTTP receiver starter process, which will listen to incoming requests and looks for parameter called USD amount, and in the send response, it's gonna convert the USD amount to an INR. Let's see how this calculates. As of today, the current USD to INR is 85.42, so I have used the current rate and converting this USD amount to INR. I'll try to test this process, and this is the USD amount parameter. I will hit with $1,000. It's converted to 85,420 INR. And for example, if I want to convert $2,000, it's going to convert to 170,840 INR. Maybe I'll just convert $1, which is 85.42 INR. And we have received multiple requests from the sample. And this is the conversion rate. I'll stop here and continue.